Google just dropped Gemini 3.7 Flash, and this time the upgrade isn't just another version number. It gets significantly better at coding, and the introductory price is cut in half. Gemini 3.7 Flash is aimed at a very specific problem: getting AI agents to finish complicated work with fewer mistakes, retries, and developer interventions. The biggest jump shows up in DeepSWE 1.1. Gemini 3.6 scored 49%, while 3.7 reaches 65.3, serious improvement for long-horizon software engineering. FrontierCode tells a similar story. The score rises from 34.4 to 43.6%. This suggests better first-pass performance on difficult coding problems. And benchmarks only matter if you feel the difference in practice. The goal here is fewer broken implementations, fewer debugging loops, and more usable code on the first attempt. Web development improves too. WebDev Arena moves from 1538 to 1588 ELO. This points to stronger performance when the model has to turn an idea into a functional interface. This is especially important for AI coding tools. Better instruction following means the model can stick closer to your design requirements instead of improvising half the interface. The bigger story is agentic coding. Instead of answering one prompt at a time, 3.7 is designed to handle longer chains of reasoning, tool calls, implementation, and correction. Google is also positioning 3.7 as a model that thinks more diligently before acting. That matters because autonomous coding becomes useful only when the model can make fewer reckless changes. Instruction following is another major focus. Give the model a constrained task, and the objective is simple: change what you asked for without creating a mess somewhere else. Token economics are still a major part of the Flash strategy. The model keeps a roughly 1 million token input window, with output capacity reaching around 65,000 tokens. And here's where 3.7 gets genuinely interesting. Its introductory API price is 75 cents per million input tokens and exactly half of 3.6's listed price. For a simple example, a billion input tokens would cost about $750 on the introductory 3.7 rate, $1,500 at 3.6 price. At scale, that difference becomes hard to ignore. Agents are particularly sensitive to token costs because one user request can trigger dozens of model calls. Cutting the price while improving coding quality makes the economics much more attractive. So if we put everything together, 3.7 isn't a revolutionary architecture shift, it's a refinement focused on making Flash substantially more capable for real developer and agent workloads. My strongest use cases would be coding agents, rapid web development, automation, and workflows where the model has to repeatedly inspect, modify, test, and continue. But don't make the mistake of treating benchmark scores that 3.7 wins every task. Hard reasoning, complex architecture decisions, and reliability still need real-world testing. So in my own testing, I would judge it differently. Can it understand the project, write the code, recover from errors, and actually finish the feature without constant babysitting? That is the real Flash sweet spot. Not necessarily being the absolute smartest model available, but delivering enough intelligence, enough speed, and much better economics for repeated production work. So who exactly should use this model? If you're building software, AI agents, internal automation, or constantly iterating on web products, Gemini 3.7 Flash is absolutely worth testing. My verdict? Gemini 3.7 Flash looks less like a flashy upgrade and more like Google sharpening the exact capabilities developers actually pay for. But I want to know what you think. Would you switch your coding workflow to Gemini and 3.7 Flash? Let me know in the comments. And if you want more AI experiments like this, subscribe to NasBuilds.